Good afternoon, friends. We are here for presentation, and our topic is sequential use of Bayes theorem. And this is prepared by Naren sir and me Ajay. First introduction. Sequential use of Bayes theorem refers to the application of the theorem multiple times in a sequence to update our belief as new data or evidence becomes available. Sequential use of Bayes theorem refers to the application of Bayes theorem multiple times in a sequence or chain of events. It is a common approach in Bayesian statistics and inference, which involves iteratively updating our prior beliefs about a hypothesis based on new information. Sequential, the general formula for Bayes theorem is posterior probability of hypothesis as given evidence E equal to likelihood of observing evidence E given hypothesis H and into prior probability of hypothesis H into marginal probability of evidence E, PE. Sequential use. In sequential use of Bayes theorem, we first start with an initial prior probability for a hypothesis and then update it with new evidence to obtain a posterior probability. This posterior probability then becomes the prior probability for the next iteration, which is then updated again with new evidence to obtain a new posterior probability, and so on. For example, it uses in case of medical diagnosis. Suppose a patient has a rare disease that can only be diagnosed through a series of tests. The first test has a certain false positive rate and false negative rate. If the patient receives a positive results on the first test, the posterior probability of having the disease can be calculated using Bayes theorem. Then, if the patient takes a second test with different false positive and false negative rate, the posterior probability can be updated again using Bayes theorem. This process can continue for multiple tests until the posterior probability reaches a certain threshold, at which point the patient can be diagnosed with the disease, means to diagnose the disease. Natural language processing. In natural language processing, Bayesian models are often used to predict the next word in a sentence. The model starts with the prior probability distribution over all possible words based on the context of the sentence so far. As each new word is added to the sentence, the posterior probability distribution is updated using Bayes theorem. This allows the model to make more accurate prediction of the next word based on the context of the sentence. Suppose we are speaking some words, then sentence, as we add more words, then you can predict what next word comes by me. This is advantages and application of sequential use of Bayes theorem. Incorporating new information. Bayes theorem allows for the incorporation of new information into posterior probability, which can lead to more accurate prediction or decision. Flexibility. Bayes theorem can be applied to a wide range of problems and scenarios, making it a flexible and versatile tool. Decision making. The sequential use of Bayes theorem can help with decision making by providing a quantitative measure of the probability of an event or hypothesis. Adaptive. The sequential use of Bayes theorem is adaptive, as the posterior probability is updated with each new piece of information, allowing for a more nuanced and informed analysis. Transparency. Bayes theorem provides a transparent framework for decision making, as the reasoning behind a decision can be traced back to the underlying probability calculation. Account for uncertainties. Bayes theorem allows for the quantification of uncertainties and can provide a more realistic assessment of the probability of an event or hypothesis. Okay, I am handling to Naren sir.
Thank you very much. Okay. Now my topic, and this is applications in various fields of Bayesian. My friend already spoke about many applications in various fields we use. So now we talk in point wise. What are the applications? First is medical diagnosis. So what kind of disease one is suffering from, to test this, there should be proper diagnosis. For that purpose, we need this sequential Bayesian we need sequential Bayesian. So after doing many tests, after doing that iterations, after doing tests many times, we can find out the most probability. We can find out the probability of the disease. Which disease must be there? At least there will be the more probability by finding out the posterior distribution. The another is finance. In finance also we see many thoughts. And then so to detect that thought and for credit scoring and risk management, for this case we use this sequential Bayesian. So another thing is about the auspicious transactions also. So what kind of transactions going on? So if there are some suspicious cases, so to find out this also sequential Bayesian is used. Another is natural language processing. So which was already spoken by our friend Azhar also, that some words we are speaking, that is it gives more meaning, more sense to hearer. Suppose I am speaking like half sentence I am speaking means there is less probability what I would speak. You cannot guess. But if I speak more words, that is you can easily guess what words he is going to speak now. So that is another is machine learning. So it is also widely used. So in net-based classification, and then Bayesian networks, Bayesian optimization, and then image recognition, and anomaly detection and recommendation systems. For this also this Bayesian is used. And another is psychology and neuroscience. So how one's brain works, how mind works, so that is also predicted by this Bayesian theory. Another is environmental science. So different kinds of natural disasters are going on. So to predict that natural disasters like floods, hurricane, earthquakes, we can use this sequential Bayesian. So now calculation, how we can calculate? Like how we would calculate the posterior distribution, similarly we can do. So first we need to determine the prior probability, and then likelihood we need to find out, and then we need to update that probability by using that prior and likelihood. And then step 4, repeat. Now what is the difference from that Bayesian theorem only and then this sequential use of Bayesian theorem is this. Step 4, that we need to repeat this subsequent tests. Okay, because like today's posterior is tomorrow's prior. Okay, so repeat that. If we repeat that, and then we can find out, we can get that posterior probability, near probability we can find. And then make a decision, and then we need to decide. And then example, there is one example, famous example is about the medical diagnosis. So you might decide to prescribe or treatment. So what kind of medicine doctor would prescribe? It's all based on this. So what kind of health outcomes now he or she is having now? After getting that treatments or after getting that medicines, what is the difference? What is the change now? So based on that, now posterior distribution is found out. So that means new diagnosis or new treatment is given to the patient. So one example is here. Suppose G, X1, X2 is directly proportional to, because X1 and X2 are independently collected samples. So G, X1, X2 is directly proportional to F, X1, X2 given theta, G theta. So for this we can write F, X2 given theta, F, X1 given theta, G theta. And then F, X2 given theta, and then F, X1 theta. And G theta, it will be directly proportional to G, X1, X2 directly proportional to F, X2 given theta, G theta given X1. So first we need to find out G theta X1, and then later on we need to treat this G theta given X1 as the prior to determine the posterior distribution. So now base theorem. what is the difference? I already told some limitations is there if we use just Bayes theorem, but sequential means now we will determine whether the sequential testing with a single test overcomes Bayesian limitations and thus improves the reliability. That means it improves the reliability of the Bayesian theorem. So that is the main use of sequential Bayes theorem. So method. So we use Bayes theorem to derive the positive predictive value. So PPV, we say PPV, and then and apply the Bayesian updating method to obtain the equation for the positive predictive value following repeated testing. So after repeating the same testing meaning there will be different prior now, because the previous posterior will be the current prior. So here is the formula. So for a given positive predictive value PPV, rho approaching k, the number of positive test iteration. So how we can find out is Ni is equals to limit rho tends to k, natural log rho high minus 1 upon high rho minus 1 upon natural log a upon 1 minus b, where Ni is number of testing iteration and a natural log a sensitivity, specificity and high disease prevalence, and k is constant. So example is here. So here is the likelihood P and then joint probability y1 to n given x1 to n theta is equals to product summation of I is equal to 1 to n and p yi given xi theta. So after, and then we need to choose the prior distribution. This is the prior distribution, and then after combining these we can update the posterior distribution. So this is the updated posterior. So conclusion is that Bayesian theorem, we use the sequential use of Bayes theorem to update the probability of event or hypothesis based on the multiple tests. Then the process involves calculating the prior probability. What we do? We calculate the prior probability and the likelihood, and then evidence. Likelihood of observing the test result given the event or hypothesis, and the evidence or total probability of all possible outcomes. And then repeating that the test, we can find out the sequential Bayes theorem. This updated posterior probability becomes the prior probability for the next test. So updated posterior probability will be the new prior test for the next observation. So final posterior probability can then be used to make decision or take an action. So based on this, suppose a doctor prescribes the medicine or diagnose the disease. The sequential use of Bayes theorem has many kinds of applications we already discussed, like medicines, finance, natural language processing, machine learning, psychology and neuroscience, and environmental science. So references are there. So thank you everyone. Thank you sir for providing us this great opportunity. Thank you everyone, my beloved friends, for hearing us.